Hello guys, today's lesson is going to be over logarithmic and exponential equations. So today is all about equations and how to solve for unknown variables. Essentially, how to solve for x in different equations that involve logarithms or exponentials. So the first thing I want us to do is just recall from the last chapter that we covered is the how to convert from logarithmic form to exponential form. If you have something in logarithmic form, all you have to do to change it to exponential form is you start with the base, which would in our case be a, the little number on the bottom, raise it to the whatever term is here, which would, in our case would be y, a to the y power, and set it equal to whatever is inside the logarithm, which is x. So pretty much these are the same statement, they're equivalent statements, they're just one's written in logarithmic form. I'll just write log for short, and this one is exponential form. Now remember, these two statements are equal. I'm not changing the value of anything. I'm just rewriting it in a different way. Think of it as two different languages. They mean the same thing. They have the same meaning. One can be English, one can be Spanish, but we're just translating it to a different form. One might be more useful than the other in certain scenarios. So let's go ahead and do an example. Let's say that we started with the equation. Anytime you have an equal sign, you have something equals something else. That's called an equation. And you want to solve for x. Log base 2 of 1 minus 2x equals 3. Now remember what this is asking. This is asking 2 to the third power is equal to 1 minus 2x. Because right now in logarithmic form, it doesn't really help us much. We can't really evaluate this on our calculator even because they don't know what log of 1 minus 2x is. We don't know what x is. That's the whole goal. Our goal is to figure out what is x. Solve for x. Figure out value of x. That's the goal. Now we could sit here and try to plug in numbers all day. 2 to the third power is going to equal to, well, that's 8, and then 8 is 1 minus 2x, etc. But what might be useful is to convert it to exponential form. So that's our first step, and I've actually already done that for us. I've already converted it to exponential form. Step 1. Exponent form. So that's going to be 2, start with little base, 2 raised to the third power, which they've written over here, and set it equal to 1 minus 2x, which they've done. You could have written 2 to the third on the left-hand side and then equals 1 minus 2x, same thing, as long as you have it set up equal to each other. So first thing we've done is convert it to exponential form, and the next thing is just solve for x. Well, I can do some solving here. 1 minus 2x equals 2 to the third. I can actually figure out what that equals. 2 to the third is just 2 times 2 times 2, which is 8. So instead of writing 2 to the third, I'm going to write 8. And this is just a linear equation, and I can easily solve for x now. I'm going to get rid of this 1. It's a positive one, so I'm going to subtract 1 from both sides. 1 take away 1 is 0, so those cancel out. I'm left with not just 2x, a negative 2x. Equals 8 subtract 1, which is 7. And then I'm going to divide both sides by negative 2, because negative 2 is being multiplied by x, so I'm dividing by negative 2. And negative 2 divided by itself, that's 1 whole, so it's just going to cancel out. I'm just going to cross it out. And I am just left with x equals negative 7 halves. If you want to leave it as a fraction, it's already simplified. Or you can write it as a decimal, negative 3.5, same thing. And there would be our answer. Okay. All right, and then you can always plug it in and make sure it checks out. If I wanted to plug it in, I'll probably just plug it into this equation right here. 1 minus 2. And instead of x, I would plug in my answer, which I'll just do negative 3.5. And I should get 8, which, what do you know? I got 8. So that's a good way to check if you were wanting to check. Okay. All right, moving on. Example number 2. We're given a logarithmic equation. We have two things that are equal to each other. Now this one actually has 2 logarithms involved, not just one log. Log base 8 of x plus 8 equals log base 8 of 15. Now notice that on my two sides of the equations, there's a logarithm on each side. There's a logarithm base 8 on the left-hand side of something and logarithm base 8 of 15 on the right-hand side. So there's two logarithms. The cool thing about this is they have the same base. Now, when there's nothing else on the side of the equation, there's no other terms that I have to worry about. There's no coefficients, no other constants that are being added. Essentially, what you can do is, you know that log base 8 of something equals log base 8 of something else. Well, if they both have the same base 8, and they're both taking the logarithm, essentially, you can pretty much just kind of cancel out the logarithms because they're the same on each side. Now, that only works when there's no other terms involved, like the next example, there's a 2 in the front, you'd have to worry about that. But there's no other terms outside of the logarithm. There's no coefficients or there's no other terms being added. So we can essentially really just cancel them out because those are the same on each side. And all we're left with is just an x plus 8 equals 15. And then you can easily solve this for x just by subtracting 8 from each side. 8 minus 8 is 0, so those cancel out. And I am left with, I'm going to write my answer up here, x equals 15 minus 8, which is just 7. And there's our answer. Okay. And you could check if you wanted to plug it in. Log base 8 of 7 plus 8, which would be 15. So it would just be saying log base 8 of 15 equals log base 8 of 15, which, of course, those are equal to the exact same thing. All right. Okay, and then example number 3. Once again, we're given a logarithm equation, and it says to solve. Now, when it says solve, the question's really saying solve for x. Figure out what's the value of x. That's the only thing we don't know. The rest of these have, number constants, 2, 5, 9. So the only thing we don't know is what is x equal to. That's the goal of this. X equals what? Well, the first thing we would do is notice that there's two logarithms in this equation, one on each side, log base 5 on this side, log base 5 on the right-hand side. So it's similar to example 2 where you can kind of just cancel them out, but you can't do that if there's anything outside the logarithms. There's a 2 on the outside of this logarithm on the left-hand side. There's 2 times logarithm base 5 of x. So we would have to get rid of this 2 before I can just kind of cancel out log base 5 on each side. We have to get rid of anything outside of the logarithms. Now, I would try to divide by 2, but all that's going to do is make me divide by 2 on the other side, and I'm still going to have a 2 that I need to kind of somehow get rid of or move into the logarithm. But if you remember, when we covered logarithmic properties, that was the last chapter that we just covered, anytime you have a coefficient, meaning a number in front of a logarithm like this 2, you can always rewrite it without changing the value by moving it to the exponent. So what I can do, I'm using my property, using the power log property. And what I'm going to rewrite it as, it's going to now become just log base 5 of x. And this 2 is going to become the exponent. Now, why did I do that? Because I want to get rid of this 2. I want to kind of move it into the logarithm. And I was able to do that using the power of logs property that we covered last chapter. Okay. Now, on the right-hand side, I haven't done anything, so I'm just going to rewrite it as is. Okay. And what I have now is I have an example that is very similar to example number 2. I have log base 5 of something equals log base 5 of something else. And there's nothing outside of the logarithm, so essentially what you can do is you can really just kind of cancel out the logarithms. They have the same base on each side. Because log base 5 of something equals log base 5 of that same value. That means the values have to equal each other, because we know log base 5s are the same. So we cancel those out, and all I have left is an x squared equals to 9. And then lastly, we're just going to solve for x. And all we have to do to get x by itself is get rid of this squared. Now, the opposite of squared is square root. So I'm just going to square root both sides. Square root and square, those cancel out. Just kind of cross them out. And I'm just left with an x equals the square root of 9 is positive or negative 3. Remember, anytime you take the square root, it could be a positive 3 or it could be a negative 3, because 3 squared is 9. And negative 3 squared is also 9. So we have x is going to be either 3 or negative 3. Now remember, this is when we first covered logarithms, which I believe was about 2 chapters ago. If I try to plug in a negative number, you will get an error. You can't ever have a negative base, which the base is 5, so that's fine. And you also can't have a negative value inside the logarithm. So if I were to plug in -3 for x, that would give me a negative value inside the logarithm. So we can't have a -3. We could only have a +3. So we're only going to have one answer, which is +3. Because you can't have a negative value inside a logarithm. So 3 was fine, +3, because if I plug it in, it would be log base 5 of +3, which is fine. If I try to plug in -3, I would have log base 5 of a -3, which again, you can't have a negative value inside of a logarithm. So even though we got plus or -3, we only have one answer that would check out, that would work when plugging in, and that would be +3. Okay, moving on. All right, next example. All right, next 2 examples involve quadratics, so it's a little bit more challenging than the previous ones. So example number 4, we have a logarithmic equation, and it says to solve for x. So the goal is to figure out what is x. Log base 5 of something plus 6 plus log base 5 of something plus 2 equals 1. Now I do have 2 different logarithms, but this is not the same as the previous 2 problems. Now some people might want to say, oh, cancel out the logs, they're the same. That's not how it works. That's only when you have a logarithm on each side of the equation, nothing else involved. And that's not the case here. We have 2 logarithms that are being added together, and it's equal to 1. So it can't be canceled out essentially like we did in the previous examples. However, I do remember when we covered properties of logarithms, that was the last chapter we covered. Anytime you have 2 logarithms that are being added together, and they have the same base, which they do, log base 5, that are being added together, you can use the sum of logarithms property, sum or product. So that's exactly what I'm going to do. I'm going to use the sum of logs property. Now what this property says is that if you ever try to add 2 logarithms, assuming they have the same base, which they do, you can also rewrite this by multiplying these 2 terms. So what I mean by that is I can rewrite this as log base 5, that doesn't change, of x plus 6, I'm going to use brackets, times x plus 2. And I like to use parentheses, so I'm making sure that I multiply everything. Equals, I haven't done anything with the right-hand side, so it just equals 1. Now I did this, I combined 2 logarithms by multiplying the inside of the logarithmic values. And that's exactly what I have here. And I use the sum of logs property, which we covered last chapter. Alright, so what I'm going to do now is I'm going to actually multiply that. So I have log base 5 of, and I'm going to multiply what is x plus 6 times x plus 2. Well, I'm going to do that out to the side. X plus 6 times x plus 2. We can either use the FOIL method or the box method, whichever one you're more comfortable with. But x plus 6 times x plus 2 is going to be x times x, which is x squared. And then I'm going to multiply x times positive 2, which is positive 2x. Then I'm going to take positive 6, multiply it by x. And I got positive 6x. And then I'm going to take positive 6 times positive 2, and I get positive 12. Now I can combine like terms, 2x plus 6x, those are like terms, so we can actually combine those. And this is going to equal x squared plus 8x plus 12. Now that's not my final answer. All I've done is I've actually multiplied x plus 6 times x plus 2, and this is what I got. So inside of the parentheses, that's actually what I'm going to write. X squared plus 8x plus 12 equals 1. So So what I've done so far is I combined these two logarithms using the sum of logs property, and I'm going to have to multiply them. I multiplied them using the FOIL method, and this is what I got. Okay. Now we still don't know what x is. That's the whole goal of this. It doesn't really prove to be useful in this form. I don't know what log base 5 of this equals to 1 is. I can't figure out what x is just by looking at that. But what we can do, if it's not useful to us in log form, we'll go ahead and convert it to exponential form, and maybe it'll be more useful to us in that form. So I'm going to go ahead and I'm going to convert this to exponential form next. And the way we do that, that's what we've been doing from the beginning examples. Start with the base, which is 5. And then I'm going to raise it to the first power. 5 to the first power. I'll write it with a pencil. And then I'm going to set it equal to whatever's inside the logarithm, which this whole thing is inside the logarithm. So that's x squared plus 8x plus 12. Okay. This is a quadratic. Remember, quadratics are anything that have x squared in them. So this is a quadratic, so my next step would be to just solve for x. Now we know how to solve quadratics. There's a quadratic formula, there's factoring, if you want to use that method. But in either case, anytime you have a quadratic equation and you want to solve for x, the first step is to always make sure it says equals to 0. Right now it says equals to 5, or 5 to the first power, which is just 5. So before I can solve it, my first step is going to be to solve for, or make this equal to 0 by subtracting 5 from both sides. 5 minus 5, that's going to cancel out, which is just 0. So I have 0 equals x squared plus 8x plus 12 minus 5 is positive 7. You can factor this, or you can use the quadratic formula to figure out what x is equal to, because anytime you want to solve a quadratic, you can use quadratic formula or factoring. So that's what we would do next. So I'll go ahead and write, you can use quadratic formula, or you can factor, whichever one you feel more comfortable with. Quadratic formula is the formula, and I'll write it out to the side. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you want to do factoring, you would just figure out what two numbers add up to 8 and multiply to 7, which that one might be pretty easy to do, but you can use either method if you want to do that one. I'll go ahead and just do the quadratic formula. X equals negative, and remember, a is 1, b is 8, and c is 7. So to solve this, I would just plug in negative b, which is negative 8, plus or minus the square root of, I'm just using this formula, 8 squared minus 4 times 1 times 7, all over 2a. And I'm going to use my calculator to help me solve that. I'm going to just type that whole thing in. Alpha, y equals, enter, negative 8 plus or minus, I can't type that in, but I can type in a plus sign, and I'll do again with a minus sign. The square root of 8 squared minus 4 times 1 times 7, all over 2 times 1. And I got negative 1. You're going to get two answers. And the second answer, well, I'm going to type in this whole thing again, except with a minus sign. I'm going to just copy and paste so I don't have to type that whole thing in again. Change that plus sign to a minus sign, and I got negative 7. So we have two answers, but remember, we have to go back and check to see if they both work. So I would go back and check to see if they both work. So if I plug in negative 1, let's just try plugging in negative 1 for x, we would get log base 5 of negative 1 plus 6, which is just positive 5, so that would be okay, plus log base 5 of negative 1 plus 2 is positive 1, so you still get a positive answer. So that would be okay, so that would just check that off. If I try to plug in negative 7 for x, I would get log base 5 of negative 7 plus 6. Negative 7 plus 6 is a negative 1. This whole thing would be negative. And remember, we can't have a negative value inside of a logarithm. So that one actually would not work. I can kind of just cross it off. So really our only answer would be x equals -1. You want this whole term to be a positive value. And if I try to plug in -7 for x, that'll make this whole parenthesis term a negative value. So that's why I crossed it off the list. Okay, and there's our answer. All right, I know that one was a bit challenging because it involved quadratics. I'm going to do one more example very similar to it, though, just to kind of get us more practice with that. Okay. So example number 5, this one also is a quadratic. I'm going to start by kind of just dividing my two sides. We have 2 logarithms. Now, there's no base written. See how there's like no little number on the bottom? Remember, when there's no base written, the base is 10. If you want to write a base 10, you can. You don't have to. You can just know that it has base 10. But I'll go ahead and write it in there, just real lightly, that it is base 10. Base 10, base 10. But you don't have to. When the base is not written, the base is 10. But the base is the same. They're both not written, which means the base is 10 on both of them. Okay, so I have 2 logarithms that are being added together, and it equals to 1. Now, you can't cancel these logs out. I know we did that on the previous examples, like on example 2 and 3, but that was because you have 2 logarithms that are equal each other. That is not the same case here. You have a logarithm plus another logarithm, and it equals a constant 1. So essentially, it's not the same. You don't have 2 things on each side of the equation that you can cancel out. However, you have 2 logarithms that are being added together. And anytime you have 2 logarithms that are being added together, they have the same base. You can use the sum of logs property, which we covered last chapter. So if you're not sure why I'm doing this, refer to the last video's notes. And what it says is that if you have 2 logarithms that are being added together, they have the same base, which they do. You can combine them into a single log by multiplying the inside of the logarithm. So this becomes log base 10, if you want to write the 10, or you can leave it off, of x, and I'm going to multiply it by the other inside of the logarithm, which is x minus 9. And I haven't done anything with the right-hand side, so I'm just going to bring down equals 1. I'll use another color. So that's what I've done so far. Now this doesn't tell us much, but I can simplify this a little bit. I'm going to go ahead and simplify log base 10 of, I can actually multiply this, x times x minus 9. We would just FOIL that. That's going to give us x times x, which is x squared. And then we have x times -9, which is negative 9x equals 1. So I've simplified, I've multiplied that out. We still don't know what x is. That's the whole goal, is to figure out what does x equal. It doesn't help me much in this form, but what we can do is let's go ahead and convert it to log or exponential form and see if we can solve it in that form. So we're going to go ahead and convert this to exponential form. And maybe it'll be more useful to us in that form. And the way we convert it is we start with the base, that's this little number on the bottom, which in our case is 10, raise it to the first power, and set it equal to whatever's inside the logarithm, so which is x squared minus 9x. It's like this little loop-de-loop. 10 raised to the first power equals x squared minus 9x. All right, this is a quadratic, so if I want to solve any quadratic that has x squared in it, all I have to do is first step, set it equal to 0. Right now it says equals to 10 to the first power, which is just 10. So my first step would be to subtract 10 from both sides, because now I'm solving for x. And I'm going to subtract 10 from the other side as well. 10 minus 10, that's 0, equals x squared minus 9x, and then minus 10. Because those are not like terms, so don't try to subtract them. Just write them separately. Now, I have a quadratic. I want to solve for x. I set it equal to 0. You can either solve it using the quadratic formula, or you can factor. Quadratic formula is that whole negative b plus or minus the square root of, I think I wrote it down right, that one. There's quadratic formula. Or if you want to factor, you would just try to figure out what two numbers add up to -9 but multiply to -10. And this one would actually be pretty easy to factor if you want to do it that way. But I know most people do use a quadratic formula, so I'll just use that one because I want to be consistent. And so I'm going to have two values for x, and that's going to be x equals, remember this is a, b, and c, negative b, which is going to be like -9 because b is already negative, plus or minus the square root of b, which is -9, make sure you use parentheses, squared, minus 4 times a, which is 1 because there's no number in front of x squared, times c, which is -10. And the whole thing is over 2a, which is 1. I'm going to use my calculator to help me calculate that. Alpha y equals, and I'm going to type this whole thing in, -9 plus the square root of -9 in parentheses, because if you don't use parentheses, you will get a different answer, minus 4 times 1 times -10. The whole thing is divided by 2 times 1. And I got 10 as my first answer. Okay. Remember, we're going to have two answers, though. We're going to have to type this in again with a negative or a minus symbol. So I'm just going to copy and paste that so I don't have to type the whole thing in. Change that plus sign to a minus sign. Enter. And there's my second answer, -1. So we have two answers essentially. You would say that those are both our answers. X can be either one of those. However, you have to go back and check, will both of those work if you try to plug them in for x. So for example, if I plug in 10 for x, I would have log base 10 of 10, which is 10 is positive, so that would be okay, plus log base 10 of 10 minus 9 is 1. 1 is positive, so that one's okay. So that one checks out. If I try to plug in -1 for x, I would get log base 10 of -1, and you can't have a negative value inside the log. So already, no, that one does not work. We would just cross it out. It does not work. And you would only have one answer, which would be x equals 10. And there's our answer. Okay. All right. Those are a little bit more challenging ones just because they involve quadratics. So not all of them will be like this, but there will be a few. So just get practice that. If you need practice, I would recommend just kind of reviewing quadratic formula or factoring if you're using that method. Okay. All right, moving on to the last page. Example number 6. So we've just solved a bunch of logarithmic equations. Now we're going to solve exponential equations. So let's start with this first example. 4 raised to the 2x plus 1 power equals 16, and it wants us to solve for x. Now we could try to plug in numbers for x and figure out what would give us a true statement. That might take a while. However, if you notice, it's equal to 16. Now the base is 4 on this left-hand side, and on the right-hand side it's just 16. Now the cool thing about 16 is we know that 4 to the first power is 4. 4 to the second power is 16. So instead of writing it as 16, we're going to rewrite it as 4 squared. And that's exactly what I've already done for us. So we have 4 to the 2x plus 1 power equals, and instead of 16, I've rewritten it as 4 squared. Now why did I do that? The reason why is because I wanted them to have the same base. Because if they have the same base, I essentially can cancel them out. I have 4 to some power equals 4 to the second power. If you know that the bases are the same, the bases are both 4, then you know that the powers must also be equal. So essentially, you can really just kind of cancel out these bases. They're the same. And you're just left with 2x plus 1 equals 2. Because the powers must equal each other if obviously the 4's equal each other. And all you have to do now is solve for x. This is a linear equation, so we can easily do that by subtracting 1 from each side of the equation. 1 take away 1 is 0, so those just cancel out. And I'm left with 2x equals 2 minus 1 is 1. And then lastly, I'm going to just divide by 2. 2 divided by 2, that's just 1 whole, so you can just cancel it out. And x is equal to 1/2, or you can write it as a decimal 0.5. And there's our answer. And you can always plug it in for x if you wanted to check that this was right. You could type in 4 to the 2 times x, which we just said x was 0.5, plus 1, and it should equal 16. And it does. And there you go. All right, last example, number 7. We have 2 parts. The first part just says solve each exponential for x. So the goal is to figure out what x equals. So we have 2 to the x power equals 5. Now if I try to list all my powers of 2, I don't think I'll ever get 5. 2 to the first power, no, that's 2. 2 to the second power, that's 4. 2 to the third, that's 8. So I never get 5. That means it's going to be a decimal. It's going to be some number between 2 and 3, because 5 is between 4 and 8, so it's going to be between 2 and 3. To try to narrow that down might be a little tricky. So instead of doing that, we're going to go ahead and let's see if we can convert this to log form, and maybe it'll be a little bit more useful to us in that form. So first thing, start with the base. That's whatever has an exponent on it, which is 2. So this will become log base 2 of 5 equals the exponent. That's how we would convert it. Now, log base 2 of 5, I don't know what that is, and remember, we can't even type that in because our calculator can't calculate anything but base 10s. That's the only it can calculate. However, last class we did use, we learned about something called the change of base formula. Which means anytime that you have logarithm of some constant, like these are both numbers, and you want to calculate that, you can always rewrite this as log base 10 of 5 divided by log base 2, or sorry, log base 10 of 2. Now if you want, you can put little 10s there if you want. You don't have to. Little bases of 10s, or you can leave them off. But those two values equal each other using something called the change of base formula that we learned about last chapter. Now this is something I can actually type in, so I'm going to do that. I'm going to type in log of 5, it has a base 10, it's not written, log divided by log base 10 of 2, and that gives me 2.3219 approximately. So I know that x is approximately 2.3219, and I'm rounding, so I'm going to use approximate symbols. And there's our x value. Okay. Now what this means, it just means that 2 raised to the 2.3219 approximately power should give us about 5. And we're rounding, so it should be about 5. It's not exactly 5 because we rounded, but 4.99999 is basically 5. So that's what that means. Okay. All right. And I just want to note, you can only use this whenever you have two constants. Like if this was like log of x divided by log of 2, you can't type that in. They don't know what x is, neither do we. So you can only type this type of thing into your calculator when these two numbers are constants, like actual number values. Okay. All right, and then last problem, part B. We're wanting to solve for x once again. 8 times 3 to some power is going to give us 5. That would be hard to just plug in numbers and try to guess what that would be off the top of our head. So maybe we can convert it to log form. But before we can do that, we have to have a base, which our base is 3. It's raised to the x power, and it equals 5. Now this 8 is unnecessary. This 8 is kind of extra. So before we can convert it to log form, we have to get rid of this 8. I should only have a base and an exponent, 3 to the x power. There shouldn't be anything other than that outside of that, which there's an 8. So my first step would be to divide by 8 first. So get rid of 8. Get rid of anything outside of the base, which the base is 3, so we want to get rid of the 8 because there's an 8 in there. So get rid of the 8. And the way we do that is we divide by 8. And I also have to divide by 8 on the right-hand side as well. And that's going to give me 8 divided by 8, which is just 1 whole, so those will just cancel out. I can cross them out. And I'm just left with 3 to the x power equals 5 divided by 8, which you can leave as a fraction, or you can write it as a decimal, up to you. I'll go ahead and write it as a decimal because it's a pretty one. If it was like a crazy decimal that continues on, I'd probably leave it as a fraction. It's a pretty nice decimal though, so I'll leave it as a decimal. Now this looks just like part A. This is something that we can easily solve. So now we can convert it to log form so that we can solve it in that way. And the way we convert to log form is we start with the base, which is 3. So this is going to be written as log base 3 of 0.625 equals the exponent, which is x. That's how we convert it to log form. Now I don't know what this is. I can't type in log base 3 of 0.625 in my calculator. I can use the change of base formula though, which we learned about last chapter. And the change of base formula just says that if you have log base of a number, of some other number, you can always calculate it with base 10. So you can also rewrite this as log base 10 of 0.625 divided by log base 10 of 3. You don't have to use parentheses, I just decided to. Now these are base 10s. You can write the 10s in or you can leave them off, it doesn't matter. Now that's something I can actually type in, so I'm going to type that in, I'm going to use alpha y equals enter. And on the numerator I'm going to type in log of 0.625. On the denominator, log of 3, enter. And I got negative 0.4278 approximately. And there we go. Now we're rounding, so this is approximately equal to x, and that's okay. Now you might be wondering, I thought we couldn't get any negative answers. No, we can't have any negative bases. The base is a positive 3. We can't have any negative numbers inside the logarithm, like 0.625, that's a positive number. You can, however, have it equal to a negative number. The exponent can be negative, and that's okay. So 3 to the negative 0.4278 power should be about 5/8, and you can plug it in if you want to double check. But that would be our answer. Okay. All right, and that's it.